Hello students. So as per your demand of this chapter, this unit, I'm going to conduct with this session with Fourier integral. As you know, this chapter I have given for the self-study, right? But still I am seeing majority students having a trouble in this chapter. So let's start with the Fourier integral. First of all, let's begin with its application. Uh, Basically, it's very much important for the electrical branch. So they are using mainly of this Fourier integral and Fourier transform. Okay, so basically its application is to determine the response of a linear variable circuit to an arbitrary impressed force. Okay, but when a Fourier integral representation of impressed force exists, the system starts from the rest. The problem is routine, but the extension to cases such as impulses like step functions and ramp functions for which the Fourier integral along the real axis does not converge may be made by the suitable changes in the path of the integration. So this one is a basically useful. So it's a basic uses of Fourier integral. Now let's start with the its formulas and its examples. So you can see here I have written three formulas. So first one is given Fourier integral and it will be used for the general formula. Secondly, I have given here Fourier sine integral and third one is it's for cosine integral. Okay. So first of all, its examples will be like express the Fourier integral, or else in another way we can say that express the Fourier sine integral, or else it will be called as express the Fourier cosine integral. Again I am repeating guys, the pattern of this unit will be express or find a Fourier integral, or else express or find Fourier sine integral, or else it may be express or find Fourier cosine integral. Okay, hope you all understood the type of the examples. Now here you can see that here I have given the formulas for this wall integrals, and the first one I'm starting with its general formula, and it's given f of x equals to 1 upon pi integration from 0 to infinite, and the another integration is given minus infinite to infinite f of t, that will be the function into the cos lambda of t minus x into dt into the d lambda. Okay, now in this formula you have to determine f of x, or you have to find some given integrals. Okay, so here you can see that here it's given two integrations. First one is given for 0 to infinite and the another is given for minus infinite to plus infinite, and f of t, that will be the functions which will be given into the equation. Okay, then cos of lambda t minus x, that will be the function and it will be as it is from into dt into the d lambda. It means first one you have to apply with the difference integration with respect to t, and the second one we will do for the lambda. But this from two integrals you have to only open a single integral which is given into the inside, that is minus infinite to infinite. Okay, so 0 to infinite will be as it is from the beginning up to the end. Okay, this one you will not open, so here you have to just integrate the term with the respect to t form only. Same you can see the another formula as I have given here, that is given for Fourier sine integral, and it's given f of x equals to 2 upon pi. In general formula it was 1 upon 5, and and for the sine integral it will be 2 upon pi. So 2 upon pi 0 to infinite sine lambda x, again it will be a function, and another limit is given again, that from 0 to infinite f of t into sine lambda t dt t lambda. Again you can see here its integration with respect to t and then after with respect to lambda, right? So it will be same like the general formula, so you have to just open this inside part of integration. So the first will be as it is, that is of 0 to infinite. So you will open only with respect to t only. So maybe you will get the answer, and that will be in terms of lambda, as we are not going to open this integration. And the last one is given Fourier cosine integral, and it will be the same like sine integral, and it is f of x equals to 2 upon pi 0 to infinite sin lambda x यहाँ पे था, और here it will be cos lambda x, again with the same limits 0 to infinite with the same function f of t, यहाँ पे था sin lambda t and here it will be cos lambda t dt d lambda. So same like sine integration, we will just open the with respect to t only. Okay, so you will get the answer in terms of lambda, lambda के फॉर्म में आपका आंसर मिलेगा. Okay, so now let's begin with the example, and here you can see that I've written the question: express the function f of x equals to 1 and 0. One limit, 1 is the function f of t, right? And that is for the limits mod x less than or equals to 1, and the another value it's given 0, and it is for the mod x greater than 1 as a Fourier integral. Hence evaluate the term I have written 0 to infinite sin lambda cos lambda x upon lambda into the d lambda. So first you have to observe two things in the questions. First, observe whether it is given for the Fourier sine integral, Fourier cosine integral, or else only for Fourier integral. So as you can see here it's given only Fourier integral, right? So आपको यहाँ पे आएगा जनरल formulas. Okay, अगर it's given Fourier sine integral, then you have to apply for the specific sine integral. And if it's given for the cosine, then of course we have to apply formulas for the cosine integral. But you can see here it's given only Fourier integral, so it will be the general formula. So we will use the first one formula. And now second thing, as I said in the description of formulas, always you have to open a single integration, okay, and that is inside part of the integration. So the first will be as it is, so we will just open the second one, and that is of minus infinite to infinite. So first, in the very first step, I am applying its formula, its general formula, as it is f of x equals to 1 upon pi 0 to infinite minus infinite to infinite f of t cos of t minus x dt into the d lambda. F of x equals to 1 upon pi 0 to infinite, and the second one minus infinite to infinite f of t cos of lambda t minus 6 dt d lambda. So just we will solve this the inner limits, and that is minus infinite to infinite, and for that you have to expand these limits as per the questions, and it's given here in the mod form. So mod x less than or equals to 1, and the second one is given mod x greater than 1, and there is a big concept behind this one limit, that minus infinite to infinite, that how it's coming minus 1 to 1. Okay, but that we will do in our next session. But till that, hope you all remember this whole formulas for the integrals, that is a Fourier integral for the general, secondly for the sine integral and for the cosine integrals, so that from the next session we can solve easily all the sums. Thank you.